Hey guys, my name's Dave. I'm with Hortitech Greenhouse. Today we are building a 20 by 20 semi-gable greenhouse. This greenhouse is going to be outfitted with truss reinforcement, double 6mm poly with inflation. We're doing steel framed end walls, a door on one end. We're hanging a heater in it. We're pretty much building this structure to withstand the elements of an area that gets a few feet of snow per year, making sure the kids are safe at the school. We're working through, we're gonna get this thing built. It's gonna be a vegetable production greenhouse. So the structure is gonna be a learning tool for the kids. It's gonna be automated for the ventilation system. So we're gonna be putting an exhaust fan in the peak of the structure. We're gonna have a shutter fan on one end of the structure so that the ridge air that's getting nice and hot can get evacuated. We're doing a passive roll-up side kit so we can use the natural environment around us to cool the greenhouse. So it's gonna be kind of the best of both worlds. We're gonna get the, the benefits of, modern ag, getting some powered ventilation in there. We're gonna get some passive roll-ups. We're building it to be structurally sound. So we're gonna kind of take you through a start to finish of this whole deal. We're gonna take you through the foundation prep. We're gonna take you through setting the posts. We're gonna take you through doing the framing, the exhaust fan systems. We're gonna talk about different systems as we go through there and build a pretty sweet greenhouse for this school. Enjoy. So right now we're installing a 20 by 20 semi-gable structure, and we just got the foundation layout all finished up. When we pulled the foundation, we made sure to leave space in each of the corners so that when Aaron marks out each of these lines, we can take these off and drill inside of this corner without having to move our string lines. We also pulled them using loops going around each of the grade stakes so that we can take them off and not lose the marks that Aaron's making. After we pulled all of the string lines, we made sure we used the Pythagorean theorem, which is doing a 3, 4, 5 in each corner to make sure that each of these are squared off. And now that Aaron's done marking each of these lines, we're gonna spray paint underneath his marks for our drilling locations for our augered holes. Then we're gonna bring the skid steer over and punch those locations out. Aaron, are you already all marked out?
Yep, I got them all.
Okay. All right. So for Aaron to make his marks, this structure was a 20-foot long with 5-foot spacing, which means that each of the columns of the structure are gonna be every 5 feet going down the length of the building. So what we did was we used a quick grip as a little hack so that we started at 5 foot at our intersection so that it was easy math for him pulling the string line down, and he could mark at 5, 10, 15, 20, and so on till he meets the corner. If he met the corner and we weren't at 20, then you know you have an issue and you got to start over. But really, this should be pretty much perfect before you start. So the first step to the process of this build was to get all of the grade stakes installed in each of the corners. You could do this process with batten board as well if you didn't feel comfortable getting your grade stakes in the right location from the start. Batten board is pretty much the same thing as a grade stake, but instead of one grade stake, you'll have two with a board across that you can put nails in the top of to adjust your string line if you don't feel comfortable getting string lines in the right locations. The purpose of these string lines for the project is to outline the outside of the structure's footprint so that when we're building it, we can set the poles on the inside of these string lines to ensure that the whole building's square as we build it. All right. So each of these corners, we measured ahead of time using the 3, 4, 5 method. We pulled 3 feet from the intersection of the corner, from this intersection out to 3 feet, from this intersection out to 4 feet. This intersection jurisdicts where the corner of our greenhouse is gonna be. And then between that 3-foot mark and that 4-foot mark, we've got 5 feet of distance, which tells me that each of these corners is perfectly square. You can follow that same procedure on the entire width of the structure on a small greenhouse to ensure that the whole structure is square, but on larger structures over 20 feet, it'll be a little difficult to make sure that you don't have sag in your tape while you're pulling it and actually pulling an accurate measurement. So in my opinion, pulling 3, 4, 5 in each of the corners, and then just making sure your overall measurements are accurate when you're done is a plenty fine way to do this. So we're gonna talk about machine selection a little bit for augering the holes for this job. Now, when you're in your local areas, everybody's gonna have to drill to a different depth with their auger based on your frost level. So we're in Central Oregon. We don't have an extremely deep frost level. There's not a lot of water in the soil, so you're not gonna get a lot of heaving. So 2 to 3 feet here is adequate for our drill depth. But if you're somewhere, that has a lot of water that freezes, maybe New England, maybe Northern Washington, Alaska, you're gonna wanna go below your frost line. It could be 4 feet, could be 5 feet. The important thing is that you have an auger bit that can get you down there, and selecting your equipment for the job is super crucial. If you have to go past 2-3 feet, you're always gonna want a bigger machine to do this job. You can rent them at your local rental yards, or if you know you have soft soil, you can usually get away with using a smaller machine, using a hand auger, using a mini skid steer, something of that nature that'll cost you a little less money. Or if you're really adventurous, you can pull the big guns out and use a post hole digger and just make it happen. But you're gonna have to really earn your greenhouse if you go that route. So my opinion is just to spend the money, get the right piece of equipment in the beginning, and get the job done right. All right, so we didn't show it before, but Aaron went ahead and marked out the end wall locations for drilling the piers because this structure has end wall kits. If you opted out of not buying end wall kits from us, you would just want to make sure you thought ahead now to get something cemented in for the main columns that are going to connect to your truss members. Otherwise, if you rented a machine, you're going to have to dig these by hand later, or rent the machine again to get back here and redo it. Pull the strings. The strings are down, the holes are marked. We're ready to start. Oh, we're fixing bad drilling. That's what we're doing. So the corners are definitely the most important. You want to make sure, since this pipe is going to sit on the inside of the corner, we don't really have a really wide diameter hole that we're working with here. So we want to make sure that that pipe is actually centered inside of that concrete. So I'm just cleaning out the inside of the hole, making sure that I got my proper depth, and making sure that the pipe's right in the middle there. Right in the middle. Yeah, so, yeah, all right. So with this build out, a lot of times, you know, you're gonna have to bring in fresh fill dirt or gravel or any of the above. And most of the time you're the homeowner, so you're not necessarily, you know what you did. But for someone like us that comes in, a big thing that we're always asking as a contractor showing up to a job site is, how fresh is this fill dirt and whether it's been compacted. And in this situation, you know, this dirt's been brought in and it's fresh, and since it's fresh, it's gonna naturally settle. So when we do our drilling, if we don't get below all of that fresh filter and that fresh material, it's just gonna settle on itself because it hasn't got a chance to be compacted from the earth yet. So just from gravity, so on and so forth. So we made sure that we drilled down and we actually got to this natural bedrock layer in here where we're hitting gravel, but we want to make sure that we got through that mulch layer and we got through all that fresh filter that brought in and got down to the native soil. Otherwise, the structure is going to move over the next 2 to 3 years. You'll start seeing shifting. All your nice work will slowly stop being level and you won't have a nice greenhouse anymore. So So, I mean, it's always good to use a form, but if you don't want to spend the money on it or it's a large project, really, a form's designed just to keep the concrete where it's supposed to be in the hole. So I use them a lot in Central Oregon because the sand, the natural soil here is very sandy. So when you drill a hole, its natural thing is to kind of fall into it. And also it kind of sucks the moisture from the concrete. So it doesn't give the concrete as good of a cure because the sand is naturally pulling moisture out of the concrete and it can dry too fast. So I like using almost a form. Really, if you have the money, just do it all the time. If you're on a budget and you're not sure it's gonna be a very permanent situation, then I wouldn't worry about it that much, you know? Left. All right, so before going on to the next step, we triple checked that all of our outside measurements were still landing on 20 feet by 20 feet. And we made sure that the tops of our sonotubes were level with grade so that after we pour the concrete and it sets, we don't essentially have sonotubes raising above the grade level and, you know, essentially causing a disturbance, looking ugly, etc. So we got all that done. We made sure that all of our sonotubes were underneath our corners and that our posts were gonna fall center in the sonotube like I explained before. All of our lines pre-marked on our truss spacing like we discussed earlier. We've got our level out, and on this job, we're gonna pour the concrete. We're mixing bags. If you're doing a larger job, I would get a mobile mix truck, or if you have a mobile mix truck, you can use them for smaller jobs like this, but it comes to be a lot more cost effective to buy bags unless you're purchasing more than 5 yards for the job. And then it makes sense to start calling in a truck between the labor and the cost savings of just getting someone out there to mix the concrete for you, get out and pour it. You want to make sure that the concrete is a 4,000 PSI structural concrete. That way it can withstand the actual load of the greenhouse. So yeah, that's it. So we're going to talk a little bit about the consistency of the concrete that you're looking for when you're doing a job like this. So what you want is a concrete that's this is actually probably a little bit wet, but it'll still work. But what you want is a concrete that's gonna sit inside the hole and allow the post to sit firm inside of it. So if it's too soupy and you pour it inside of that hole, when you put the post in, the post after you level it isn't gonna set itself up. So we'll shove this in the hole and we'll level it out and give you an example. Oh, this is gonna be fun. All right, Aaron. Talk to me.
Forward. Tilt this way a little bit. We're about halfway full. A little more. Right there.
So what Aaron's doing now is we got all the posts set. They're on the inside of the string line, so the dimension of the structure on this spec was overall, so 20 foot outside to outside. So all of our posts, which we put in on our 5 foot spacing on our marks, are on the inside of the string line because our string lines were mounted to 20 feet. Now, we filled up each of our sonotubes, we put our pipes in, we made sure that they were engaged 2 feet down. So, you know, I usually just use a point of reference. You don't have to be exactly perfect with how high this tube is coming out of the ground. You just want to make sure that you're hitting your sidewall minimum. And your minimum on this structure is 6 feet because we have a 6 foot sidewall. So I know 2 foot's in the ground and at least 6 feet is out of the ground. So I'm not that tall, so it's surpassing me, but that's a personal problem. Now, what Aaron's doing is when he put them in the hole, he made sure it was level this direction and this direction. So against the string line and with the string line. So that way we make sure that this post is actually truly level, left and right. And that makes sure it's good. So we already did that on our first pass through when we set our post, but the concrete was still a little wet. So right now he's going through, he's double checking everything for its final set. And then we're gonna leave it to cure over the weekend in this case because it's cold outside, as you can see, but it's still just warm enough where it's fine for the concrete. So we'll let this set for the weekend, and then once it's completely cured, we're gonna come back through and we're gonna run a transit, which is a 360-degree laser. And that's gonna give us our locations on the top of each of the posts, which we're gonna cut level. And that's why we don't care about the distance it's coming out. And that's why we don't care that these tops are exactly the same, because we're gonna laser those in and cut them completely level. And if you didn't have a 360 laser, you could use a string line with a string level. It's just a cheap alternative. Or no, really you should just use a string line or a 360-degree transit. Feel free to comment if you know any other ways to do it.